And the first one is Matteo Romano. He did a master's here at university, and in his master's thesis he looked at this topic. So he will be presenting on the equivalence or inequivalence of the theories of general relativity and Spin-2.
Thank you. Thank you also for inviting me to this workshop. And yeah, I will present my master thesis project. And I will focus basically mostly on equivalence between the theory of Spin-2 gravity at a classical level and the theory of general relativity. So very fast, what is the line of my presentation? We present the two theories, and I will discuss the aim of the project, that is indeed try to find out the level of the equivalence between these two theories. In particular, I'm going to discuss the core of the self-interactions of the graviton, that is the fundamental element that try to link the two theories. I will analyze this fundamental feature, and I will see how different authors approach to this program in a different way, in order to show that the different path and the different solutions that the authors find are independent of from the initial commitment that they have regarding the physical object of the theory and their interpretation. So let's start by saying, okay, was this Spin-2? I mean, before me, I think it was already a bit described, but the idea is that at least at a classical level, that's what I'm focusing on. Spin-2 gravity can bridge the gap between the standard model and general relativity, and so to describe the gravity not as general relativity, but as a field that is self-interacts within itself. In particular, the idea is that exactly the self-interaction of the graviton can reproduce the feature of general relativity. And what I will argue is that actually the self-interaction cannot be solved without already committing to some interpretation of the physical objects that are in place. So I'm intending that we should commit to the level of ontology of the physical element and their explanatory value. And it's in this sense that I'm talking about equivalence, in the sense that I'm considering theoretical equivalence as two theories have theoretical equivalence when they agree on what the physical world is fundamentally like. So it's not only a relation on the mathematical formulation of the two theories, but it's also a relation about interpretation and how this formulation is interpreted. And so I argue that Spin-2 and general relativity, they are not only inequivalent in their full interpretation, but more to that, they have also two mathematical formalisms that cannot be translated into each other without committing to at least some of this interpretation. And so I will now describe a bit the fundamental element of this theory. As for me, it has an important role, the interpretation we give to the theories. I'm already considering Spin-2 and general relativity with respectively with their dynamical interpretation and geometrical interpretation. And so I was considering Spin-2 as a flat background on which the field of the graviton H self-interact, and the metric is just a codification of the matter symmetries, while general relativity is indeed the curved space-time or only one dynamical metric G, and is the metric that explains the matter's behavior. And so we have that we find, I will analyze different attempts to try to bridge the gap between these two apparently very distant theories by different authors that claim to bridge a gap at least at the mathematical level between these two theories, but actually their attempts are strongly dependent on their initial commitment, and also the result they get is just a mirror of what are their initial intuition about the physical element of the theories. In particular, I wanted to...
Can I ask a question? So,
yes.
When you say GR, do you mean classical theory or do you mean...
Yeah.
And when you say spin-2, do you mean classical? Pure classical.
Yes.
But what's the point? I mean, what does it mean spin-2 classical? There is no meaning.
I mean,
well, I guess there is. I withdraw the statement. There is.
yeah. Then, yeah, of course,
Yeah.
then, so the fundamental characteristic of the formalism that are trying to be translated in these approaches are this. So the idea that the metric G can be written as the sum of the background metric plus the metric of the graviton, and the idea that we can translate the diffeomorphism invariance of the graviton as the general covariance of the general relativity, and also the idea that in some sense there is a link between the equivalence, the strong equivalence principle, and the minimal and universal coupling. But what I argue is that all these features are not feature on only of the formalism of the theory, but actually they encode already part of the interpretation. In particular, the strong equivalence principle encodes a big part of the geometric interpretation of the of general relativity, and so it cannot simply be translated on assumption on the coupling. This translation does not work, and in particular, if we start from a spin-2 background, then we should in some way revisit what is the equivalence principle we end up. And I thank Ian and his work for helping me figure this out better. But although I end up with a slightly different conclusion at the end, we can discuss this later. So let's present what is the self interaction and what are the problems that arise in construct the bridge between these two theories in this way. And again, I want to thank Niels, Chris, and Mark to give me a guide in this, not only in the self interaction, also in what are the problems of the energy tensor that we will discuss this later. Let's start from the fact that the self interaction can be can be done at the level of the equation of motion, and in this case we are talking about self-coupling, self-sourcing, or at the level of the action, and then I will talk about self-coupling. Let's start from the equation of motion. So we have the equation of motion of the free field of the theory, and then we want to source it, so we add the stress energy tensor, but for conservation of the left-hand side, we cannot just add the matter stress energy tensor, but we are forced to add a correction, that is the gravitational energy tensor. This correction, though, depends on the field H itself, so require another correction of higher order, and that still depends on H, and so on. And so we are forced to add an infinite number of corrections that we expect that can be summed up and obtain on the left-hand side the Einstein tensor, and so the Einstein equation. For the variational principle, we also expect that this can be brought at the same time at the level of the action. And so again, we start from the first Pauli action, that is the most general action we can write with the quadratic integral derivative of the field H up to some surface term that I will discuss. And the idea is, again, we have a coupling there, and this needs another correction of the action of higher order, and so on. This will sum up at the end, and the aim is to again find the Hilbert-Einstein action, but actually this cannot be fully recovered because the Hilbert-Einstein action is linear in H, while we started from an action that is quadratic in the field.
Sorry, what is big G?
What is?
Big G.
The Einstein tensor.
Okay.
And yeah. And so already on how this is structured, we should committing sometimes to some part of this interpretation. First of all, on what is the role of the action, what physical meaning we gave to it, why we can discard the surface term both at the beginning in the linear theory and both at the end in the Hilbert-Einstein theory, especially in a theory where the bulk and surface term are strictly related as in GR. And more to that, also the source and the coupling cannot be the same object because there is this dependence on H. So this shifted us a bit from the usual field theory grounds, and then we are forced to ask ourselves what of these two objects is the energy tensor. So once we give physical meaning to which one of these two, and which one of the other is just a mathematical consequence of the first one. And more to that, we have the problem of the definition itself of the gravitational stress energy tensor. Since in all this approach, what the tensor, the energy tensor is defined using Weber prescription. That means covariantize the action, so make it explicit the dependence of the volume element with the metric, promote the ordinary derivative, covariant derivative, then take variation of it, and then go back to the limit. And this is preferred because it's already a symmetric definition of the tensor. It has a natural way of course, covariantize this definition, and apparently solve some of the ambiguities of the canonical definition. But actually, these solutions are not really solutions because, first of all, the ambiguities can be still hidden in the possibility of add non-linear coupling to the action when we covariantize it. But also, if we consider a linear couple approach, still what the definition is just select one of the many possibilities of the canonical tensor, and I will say that the choice of it was said that the choice of this selection is parasitic on general relativity, on its kinematical content, and also all the other features like the symmetry and the easy covariantization all came from the fact that the definition itself came from a different framework from Spin-2, but came directly from the framework of general relativity. And this is more problematic, especially in the fact in the moment in which this definition is fundamental to perform the self-interaction program, because allows us to arrive to this recursive differential equation that can be solved exactly because of this definition. So I will try to briefly describe some important elements of how the different authors approach these problems and how they decide to give physical meaning to the coupling or to the tensor, and then how the path diverge from that. And all of them justify all their steps using the element as again of diffeomorphism invariance, general covariance, and the equivalence principle. And I want to try to show that these prescription for them are not just prescription on the mathematical formalism, but actually a prescription on already the interpretation that they are giving to the theory. And this is even more strong when the program is just a reverse engineer program. So let's start from Padmanabhan. He starts his theory from the first Pauli action again, and as said, is discarding some surface there that are the one that came from the possibility of switch ordinary derivatives in the action. But when we covariantize the action, then the exchange of the covariant derivative is not trivial, and then we end up with the extra term. So already the decision of discarding this term and of the meaning of the action in this term is already a matter of interpretation. And also he asked the energy tensor to be the coupling, so he's giving more physical meaning to the coupling than to the source. And this forced him to use an covariantization scheme from the energy tensor. And he justified this path, saying that he does not want to assume general covariance. But again, general covariance has no physical meaning by itself. Every theory can be written in a general covariant way. But what he actually meant is that he's translating part of the equivalence principle and of the interpretation of the geometrical part of the GR already inside the prescription of general covariance. On the other side, Barceló prefer the tensor, the source to be the energy tensor of the theory. And so again, we have the same problem of distinguish between source and tensor, and it's also starting from the first Pauli action, and it's also discarding the same surface term as before, but now it's justifying in him claiming the necessity of required ecomorphism invariance, but also in this case, although this requirement actually impose us to promote the background metric to a dynamical object, still it does not encode all the physical and explanatory value that for Barceló is important when he does this step. And this step for him is also coherent with this interpretation of a bimetric theory, because what he ends up with is not like the interpretation of GR that I said before, but it's a bimetrical interpretation of general relativity. And indeed, for him, promoting the background metric as a dynamical metric is an assumption, and then also in some way a result because of this. And asking the energy tensor to be the source this time allows him to do a full covariantization scheme. And in this way, his solution is again already naturally general covariant. But this again is very compatible with this interpretation of the geometrics. But more to that is forced to add non-minimal coupling in the definition of the tensor in the form of superstars. And in this case, though, his minimal coupling for him are not a problem because they just are a parameterization of the hyperprescription of the theory. And because again, the equivalence principle is not translatable directly as a prescription of the coupling. So there is no direct consequence of asking for a non-minimal coupling. And at the end, the Desser and Batcher et al. Are on the other side using a reverse engineer problem, and they are actually showing how self-coupling the first Pauli action with its own stress energy tensor does not lead actually to general relativity, but you are forced or to start from a different action that is not that cannot be guessed only from a field theory consideration, or to use a different energy tensor again. But what I will argue is that in this case, since we start from inverse tensor action, go all the way back, saying that what we get at the end is actually a free theory of a graviton and its physical energy tensor is not a trivial step, especially when this derivation deeply rely on the fact that there is only one physical metric, and we can mix the degree of freedom of H and beta. And yeah, beta. And so, yeah, these are the overview of this approach, and how the fact that it is this plurality of approach is also for me a symbol of the fact that how these are strongly dependent on the interpretation. And so my conclusion are that Spin-2 gravity, knowledge interpretation, and general relativity are theoretically equivalent, not only with the full interpretation, but also because there is no way to translate the two formalisms one into each other without committing to some element of this interpretation. And so I will argue that we cannot use the self-interaction scheme to guide our interpretation of general relativity and to understand what are its fundamental features, because these are actual assumptions of the program, not a result. So thank you.